If users click results and instantly bounce, we'll add highlights and clean snippets so they can see why a result matched. Search results are only useful when people trust them fast. If a result looks wrong at a glance, users leave. By the end of this video, you will understand how to build compact, explainable snippets that show the exact matched words and why a result ranked. You will see how to tune snippet length and presentation for better click confidence. I'm Professor Pi, teaching Search and IR with Simple Python. Whoosh is a pure Python search library that is perfect for demos and small to medium collections. People reach for Whoosh when they want searchable text without running a full search server. Highlighting and snippets solve a common UI problem. They turn opaque matches into readable evidence so users can judge relevance instantly. At a high level, a snippet is a short excerpt from the stored text that contains the matched term. A formatter marks the matched words. A fragmenter picks a window around the match so the excerpt is not too long. For example, if a long document contains the word relevance in the middle, the fragmenter extracts a short sentence around that word, and the formatter makes the words stand out. The trade-off is context versus compactness. We will build a tiny in-memory Whoosh index, add 2 toy documents, run a couple of queries, and then generate highlighted snippets with different formatters and fragment sizes so you can see how the UI behaves. Now we will create the index and add the first document. This snippet builds a Whoosh index in memory and adds 1 document. It defines a schema with an ID and a stored text field so we can later render snippets directly from results. RamStorage creates an in-memory index, avoiding file system setup and keeping the demo fast. The writer adds a single document and commit finalizes the segment. The printed count confirms the index is ready for querying and snippet generation. In plain terms, the schema tells Whoosh which field stores searchable text and which field we can return intact for snippet extraction. Using memory storage keeps the example simple and repeatable. Next, we will append another document and run a simple query to test ranking. This snippet adds a second document and runs a first Whoosh query. The writer appends a new record so we can test ranking across multiple candidates. QueryParser turns the user text relevance into a parsed query over the text field. The searcher executes BM25 scoring and returns the top hits. The printed top ID shows which document is most relevant, verifying basic retrieval works before we layer on snippets. BM25 here is the default scoring that rewards term frequency and penalizes overly long documents. Seeing the top document lets us confirm that the index and scoring behave as expected before we decorate results with snippets. Now, we'll make matched terms visible inside result excerpts. This snippet enables Whoosh highlighting, so matches are visible in results. QueryParser builds a query for relevance, and the searcher returns ranked hits. Setting UppercaseFormatter makes matched terms appear in uppercase inside the snippet, which is a clean, tag-free emphasis. Calling highlights on the first hit generates a short excerpt from the stored text with the emphasized term. The printed snippet shows why the result matched, improving instant interpretability. Using uppercase is helpful for demos because it is readable without HTML. But in a real UI, you can choose HTML or bracket-style formatters, depending on your rendering layer. Next, we'll control how much context the snippet shows with a fragmenter. This snippet controls snippet length with Whoosh's ContextFragmenter. The query for dense selects the second document, then UppercaseFormatter emphasizes the match. ContextFragmenter chooses a window around the hit and trims the excerpt to a target size. The highlights call returns a concise, readable snippet centered on the matched term. Increasing max chars gives more context but longer UI lines. Decreasing it shortens output and can hide context, trading clarity for compactness. The fragmenter is the main knob you tweak when results feel too chatty or too cryptic in a search result card. Finally, we'll produce a user-friendly snippet for a query with multiple terms. This snippet assembles a user-facing snippet for a multi-term query. QueryParser combines dense and BM25, so scoring rewards results covering both. The searcher returns the top 2 hits, then SimpleFormatter wraps each match term in brackets to clearly mark multiple hits. Calling highlights on the best hit produces a final, display-ready snippet with both terms visible in context. The printed snippet shows exactly why the result is relevant, ready for a result card. Showing both terms together helps users validate multi-term queries like feature plus model or error plus code sample. In a real project, you would map this flow to your search endpoint. Store the document text or a short summary so Whoosh can return the stored field. Generate snippets on demand in the Search API and render them in your web or mobile UI. For larger collections, consider swapping in an external index or a more scalable search engine, while keeping the same snippet logic at the UI layer. Recap what it is: a small Whoosh pipeline that indexes text, scores with BM25, and produces highlighted snippets. When to use it: for demos, help centers, or product search, where lightweight and explainable hits matter. One caveat: Whoosh is best for small to medium data. For very large corpora, you will need a more scalable index. Next step: tune BM25 parameters K1 and B to see how relevance ordering changes and how that impacts which snippets you show. If short practical IR helps you, subscribe and watch the IR videos.